Although not quite inside my house, nanotechnology plays a surprisingly significant role in the automotive industry. In this video, I will show you some of the areas where they are used. Normally, cars use internal combustion engines, which use fuels such as gasoline and diesel that are derived from petroleum. Therefore, these fuels often contain different types of hydrocarbons. Nanoparticles are often added to create a cleaner combustion. Due to their relatively small size, nanoparticles have a large surface area to volume ratio, which can change the chemical properties of a fuel. For example, it can increase the energy released per unit volume, or lower the pressure and temperature required for combustion. This creates a more efficient fuel that emits fewer emissions during combustion. The nanoparticles help create a better air-to-fuel mixture. Some even release oxygen during combustion. This makes the process cleaner and release more energy. Several popular additives which have these properties include cerium oxide, cobalt oxide, and aluminium nanoparticles, which are often mixed with magnesium. However, sometimes these nanoparticles are exposed to the environment. Due to their small size, they can travel through our body quite easily. The consequences of this is not yet well known. Nanoparticles may also be added to lubricants or coatings on the inside of the engines. This helps reduce friction and enhances thermal conductivity, which in turn improves efficiency and reliability of the internal combustion engines. Proven examples of such nanoparticles include aluminium oxide and silica. These additives have similar limitations and are also expensive to produce. In the future, nanoparticles may help in the production of synthetic fuels. These use carbon from captured carbon dioxide and hydrogen from water. These synthetic fuels would be completely carbon neutral and use the same, normal, internal combustion engines. Another area where nanoparticles are used are in the paints and coatings that put on cars. Their main role is to prevent scratches and dirt from harming the paint. Aluminium oxide and silica are often used for this purpose. Self-assembling monolayers can also be used to prevent corrosion, as was seen in lecture number 4. Self-healing coatings are also being explored, where molecules can rearrange themselves after a dent or scratch. Nanoparticles are also being used for better adhesion between paint and metals for more durability, and also to create hydrophobic layers on mirrors and glass to prevent glare. Nanotechnology is also used for better aesthetics. For example, BMW have created a car with Vanta black paint. This uses carbon nanotubes, which reflect almost no light at all. Finally, the tires of a car also use nanotechnology. It is mainly used to improve the durability of a tire, so that there is less wear of the tread or surface of a tire, which contain many edges. Also, the structural integrity of a tire should be optimized, so that there is less rolling resistance and more fuel efficiency. In the present, silica and carbon black nanoparticles are used, which give the tire its black color. Many new nanomaterials are also being developed as additives to the rubber compounds. Toyo tires use something called nanoprene, which interacts with the rubber compounds via hydrogen bonding and dipole interactions. Bridgestone are developing something called nanoprotec, a coating that helps tires generate less heat. Finally, tires with carbon nanotubes are being developed, which are stronger and have harder composites. There are also other applications of nanotechnology that are worth mentioning. For example, in catalytic converters, which convert harmful emissions such as carbon monoxide into less toxic gases. They often use platinum particles as a catalyst, which like to clump up together at high temperature. New nanomaterials are being developed which prevent the platinum particles from clumping, so that more surface area is being exposed and more chemical reactions can take place. Also, new metal alloys, polymers, and plastics are being developed for the chassis and body of a car. These cause them to be lighter for fuel efficiency and stronger for safety. Modern cars are filled with computers and sensors. And in the future, we will need faster and smaller computers for self-driving cars. Finally, it is possible that in the future, cars will use hydrogen fuel cells instead of internal combustion engines. However, hydrogen fuel cells are still very expensive since they use platinum. New, modified carbon nanotubes are being developed to replace the platinum altogether, which makes the hydrogen fuel cell far cheaper and thus economically viable.